Not audible. Yeah, now audible. Audible.
Audible, sir?
Yes, audible.
Yes. Respected Vice Principal, today's chief guest of the function, Dr. T. Venugopal, faculty colleagues, and my dear students, a warm good morning to one and all. On behalf of PHG Tech and Mathematics Department, I have the great pleasure to welcome you all for the National Mathematics Day celebration. I'm happy to welcome most especially the speaker, Dr. T. Venugopal, Professor, Department of Mathematics and Computer Science, Sri Satyasai University of Human Excellence, Karnataka. The title of the professor's talk is A Bird's Eye View of Ancient Indian Mathematics. It's an interesting topic. We thank you, sir, for honoring our invitation in spite of your busy and tight schedule. To commemorate 133rd birth anniversary that falls on 22nd December of an unparalleled genius and a self-taught mathematician, Srinivasa Ramanujan, Mathematics Department of PHI Tech is celebrating National Mathematics Day today. Dr. Manmohan Singh, former Prime Minister of India, has declared 22nd December as the National Mathematics Day during 125th birth anniversary celebration of Srinivasa Ramanujan held in the year 2012 at Madras University. Since ancient times, various scholars had made significant contributions to mathematics, including Aryabhatta, Brahmagupta, Mahavira, Bhaskara II, Srinivasa Ramanujan, etc. At a very young age, Srinivasa Ramanujan showed the signs of an unfolding genius, and his contributions regarding functions, infinite series, number theory, mathematical analysis, etc., set an example in mathematics. Now, about Srinivasa Ramanujan and his contributions in mathematics. Srinivasa Ramanujan was born on 22nd December 1887 at Erode in India and died on 26th April 1920 at Kumbhakonam. His family was of Brahmin caste and lived in poverty. At the age of 12, he had gained knowledge in trigonometry, and without anyone's help, he had developed his own theorems and ideas. Do you know that at the age of 15 only, he obtained a copy of George Schuberger's synopsis of elementary results in pure and applied mathematics? He had spent his childhood days in great difficulty in poverty. He used to borrow books and read books from friends in school. When he was young, he took up the job of a clerk to meet the economic needs of the house. And when he gets time, he used to solve mathematics questions and worked on various types of theorems. Once an Englishman saw those pages, was impressed, and took a personal interest. He sent Srinivasa Ramanujan to Hardy, the professor of Oxford University. He then recognized the talent hidden in him, and thereafter he got fame worldwide. His papers were published in the Journal of the Indian Mathematical Society in 1911. He had compiled about 3,900 results, mainly identities and equations, that too on his own without anyone's assistance. Several results out of them are original and novel, like Ramanujan prime, the Ramanujan theta function, partition formulae, and Mach theta functions. These results further inspired several other research and opened new fields of work. He discovered his theory of divergent series, worked out the Ramanujan series, the elliptic integrals, hypergeometric series, and the functional equations of the zeta function. The number 1729 is known as Hardy-Ramanujan number. The main objective behind the celebration is to raise awareness among people about the importance of mathematics and the integral part it plays for the development of humanity. Once again, I welcome you all. Thank you. Now we request Dr. Chitra to introduce the chief guest. Good morning to everyone.
It's a great honor for me to introduce today's chief guest, Dr. T. Venugopal, Professor of Mathematics, Department of Mathematics and Computer Science, Sri Sathya Sai University for Human Excellence, Karnataka. He is formally associated with Sri Chandrasekhendra Saraswati Vishwa Mahavidyalaya as the Controller of Examination, Director, Research and Publication, Dean, Arts and Humanities, Head, Science and Humanities, Professor and Head in the Department of Mathematics. He is a best outgoing postgraduate student of St. Xavier College, Palayamkottai. He has qualified in CSIR UGC NET and he is a recipient of prestigious junior and senior research fellowship during his research at Madurai Kamarajar University. He has more than 22 years of teaching and research as well as academic experience at university level. He has a research interest in operation research, management science and modeling, business statistics modeling, interrelation between mathematics and service operations, interrelation between mathematics and computing, discrete and applied mathematics, applied graph theory, ancient Indian mathematics and Vedic mathematics, teaching methodology and Vedic techniques, mathematics education, education in human excellence. And he has also interest in collecting and reading books in mathematics and spirituality. He has own library of 500 books, more than 500 books, and more than 10,000 e-books for the subject on mathematics as well as in the value education. He has published more than 52 papers, research articles in Web of Science and Scopus and peer-reviewed journals, and more than 39 articles in conference proceeding along with his scholar. And he is author of 6 books in the area of mathematics and 5 more books under preparation. He received the Best Teacher Award from SCSVMB in the year 2014. He is also a member in various committees, doctoral committees in Evaluator, PhD and MPhil thesis evaluator in universities, member of Board of Studies in various colleges and universities. He has delivered more than 30 talks on mathematics and more than 55 talks on spirituality. He is a life member in various bodies as well as in various, he is also an editorial board member of various journals and he is also a reviewer of various journals. So during this pandemic, he has delivered more than 15 online workshops. Few of them are operation research through Microsoft Excel, applied business statistics through Microsoft Excel, school and college mathematics through open source software, and automata theory and theory of computation through JFLab. He has also done a lot of reforms during his tenure in SCSVMB. Few of them are branch-specific papers and weekly mathematics research colloquium, trained the entire department on teaching mathematics through software, established Hindi department with UGC seed money, bridge course for few entrants, and engineering primer book for new entrants, software for the student database through instructor and document-based counseling, establishing research and publication wing and university printing press, exam process reforms, including on-screen evaluation, automatic question paper generation, biometric entry, mark sheets with security features and CCTV surveillance, etc. With these few words, now I request our distinguished chief guest, Professor T. Venugopal, to address the gathering and to give his precious input to our dear students. Thank you, sir.
Yes, I will take over shortly. I will start my presentation. Just wait a moment. Yeah. Hope you are seeing my presentation.
Yes, sir.
Professor.
Yeah, I will start. Yes. Thank you. Very good morning to all. This is Professor Dr. Venugopal, working currently in the Department of Mathematics and Computer Science of Sri Sathya Sai University for Human Excellence, Gulbarga. This institution is run by a trust which runs over 30 schools free of cost, and this university is also free of any fees. I am proud to be part of this university. My pranams at the lotus feet of Bhagavan Sathya Sai Baba and this Bhagavan Sri Madhusudan Sai. Let me, these are my contact details. In case you want to get in touch with me, you can do so. My talks are there on YouTube channel, the talks which were given during this pandemic. And I'm on LinkedIn, Twitter, and WhatsApp. If you have any further need to contact me, you can do so. This is on a bird's eye view of ancient Indian mathematics. This is a National Mathematics Day talk organized by PSG Institute of Technology and Applied Research, Coimbatore, in association with the chapter of Institution of Engineers. Today, I am at the outset, I thank the management of and the Department of Mathematics of PSG Institute of Technology and Applied Research, Coimbatore, for having invited me to address this gathering. I understand that the first year engineering students are there. And we will have, as the title suggests, we'll have a quick, I'll be thankful if other mics are muted. Yeah. A bird's eye view of the ancient Indian mathematics, as the title suggests. I will give a very rapid introduction to the
What are rapid?
To the ancient Indian mathematics. Yeah, I think I have unmuted myself. Right. Hope I'm audible. Yeah.
Yes,
Disclaimer, the content of this talk has been taken from various books. I acknowledge with due thanks. I will show the books to you. And I am only responsible for the flow of the presentation. So nothing original out of me. This talk is an attempt to introduce this ancient Indian contribution of mathematics to young minds, while acknowledging the contributions from all schools of thoughts from all the countries. For example, this is taken from storyofmathematics.com. We have prehistoric mathematics, Sumerian, Babylonian mathematics, Egyptian mathematics, Greek mathematics, Hellenistic mathematics, Roman, Mayan, Chinese mathematics, Islamic mathematics, European mathematics, and Indian mathematics, the topic of today's talk. See, understand that so many of our ancestors in across the world have taught in this direction, have taught about mathematics, have taught about science, and we are standing on their shoulders. This one book I will be referring often is Bharatiya Ganitam, Indian Mathematics in Sanskrit Concepts and Achievements, published by Rashtriya Sanskrit Vidyapita, Tirupati. I have the hard copy of this book. From there, I will show certain glimpses. This book is also available. And another book, Scientific Thoughts of India by Sri Krishna Nambudiri, for which I have written the foreword also. From this book, I will show certain glimpses. And certain other books are also there, which we will not see now, but I can share. These are certain books which can be read in case the students are interested. Okay. The ancient Indian leaps into mathematics, Indian mathematics, the history of ancient Indian mathematics, like that. Before getting into that, I would like to tell you a small story, which is which I have heard often. This is about a lion cub among sheep. There was a famous story on this. A lion cub which entered accidentally the flock of sheep, and it was staying there along with the sheep, taking grass and all. One day a lion came to hunt this sheep. Suddenly it saw there's a lion cub in the group of sheep. So the lion uh, went up to this cub, but this cub was struggling. I'm sorry. I'm hearing some other music. Kindly mute. Yeah. This lion went up to it, but this lion cub was trembling. It says, "Oh, no, no, I am a sheep. Please don't hurt me." This lion said, "No, no. What do you say? You are a lion." "No, no, I am a sheep." Please. No, the lion took the cub to a pond, showed the reflections of both over there, had a mighty roar. Then this lion cub understood that it's no longer a sheep, it's a lion. It has a heritage. His father's forefathers are a lion. So it had that feeling. Why did I tell this story? It's now being increasingly recognized that ancient Indian literature contains profound wisdom of scientific knowledge, but unfortunately, we have lost that awareness of the contributions made by ancestors. What's a loss? Our ignorance about the richness of our heritage has made us lose our sense of pride for what is ours. See, if I say, suppose a boy is there in a village, poor, okay, and he thinks he is poor, disabled, and all that. Suddenly, somebody comes and tells him, the grandfather of your grandfather of your grandfather of grandfather was a king, right? So you have come in the progeny of kings. So this boy suddenly feels proud, right? So if you know your history, if you, that's why we study history, we study this ancient, not that we have everything now. No, we cannot say, see, but were the ancient people aware of mobile phone, were the ancient people aware of Zoom meeting, were the ancient people aware of calculus, trigonometry? You can keep asking, but the thing you should have in mind that they had the ability to think. Whatever, see, earlier days there was Pushpaka Vimana, and you can call it fiction, or you can call the way they could think about a machine that flies those days. So in Western literature, it's called what do you call a story. Okay, so our that ignorance should go, and we should feel feel proud of our heritage. What our ancestors came to know, our ancestors were capable of thinking logic, were capable of to that whatever the need of the day. Okay. As a result of this, our sense of confidence in our own capabilities have also gone down. See, so once you see that I don't have any heritage, I'm then I feel low. I feel low. I don't have big heritage. I'm a small boy. So if you know your heritage, then you know that our forefathers could think this had this much wisdom. Then what prevents us from going ahead? Okay, that pride will come to us. Yes, we will get into the topic. I will show you certain. Now, you have ancient Indian mathematicians dating from 800 BC to 1690 AD. Many are there. Baudhana, I mean, Baudhayana is there, Apastamba is there, Panini was there, Katyayana was there, Aryabhatta was there. Okay, so many are there. Even in Jain, Buddhism, and this Hinduism, The mathematicians are plenty, not only mathematics, all science were studied by them. Yes. The 5 ways in which the ancient India changed the world with mathematics. What are they? Important ones taken from the website conversion.com. The number system, the concept of zero, solutions to quadratic equations, rules for negative numbers, basis for calculus. So one thing I would like to tell you, this need only breeds inventions. Initially, there was a need to count. There was a need to count. So they started counting with fingers. 10 fingers were enough for them, right? Nothing big. You give me 2 apples, I give you 2 guava. Matter over there. So I didn't need beyond 10. So when they started doing business, when they started selling things, they needed more numbers. So they developed more numbers. And there was a discussion about there was a need for profit and loss. Then the need for negative numbers stepped in, right? Then there was a need to divide things among people in certain ratios, half to you, half to me, one fourth to you, three-fourth to me. There was a need for ratios, the ratios set in. And when people started building rooms, then the concept of measurement came in. Then they started thinking, see, the need for irrational numbers also stepped in, because they wanted to know what would be the hypotenuse of a triangle with side 1 and 1 for a room. Okay. They got entered into this irrational numbers also. You will be surprised to know our ancestors knew about irrational numbers also. So let us briefly see these 5 first. The Vedas, in the Vedas, numbers were constantly expressed as combination of powers of 10. See, that is one. The concept of zero, so widely known that zero is introduced by India. How? I will let you know a bit later. Not only a placeholder symbol in Western, this thing, they were using it as a placeholder symbol, okay? But we were using it for even computations. Then quadratic equations were there, where they were formulated in the Siddhanta, Brahmagupta Siddhanta. Then negative numbers were also there. A fortune subtracted from zero is a debt, and a debt subtracted from zero is a fortune. Such concepts were there by Brahmagupta. Then the basics of calculus were also laid there. See, they started talking about equations. Okay, that was there. So to the need, to the extent, mathematics were needed in those days. Had Bhaskara been there today, he would have developed all this new mathematics that we have, that the modern mathematicians have developed. Okay. The mantras, if you get into mantras, they invoke powers of 10 from 100 all the way up to a trillion. Okay. So there were operations of addition, subtraction, multiplication, fractions, squares, cubes, and roots. Buddha, textbook related to Buddha, enumerating numbers up to 10 to the power 53. It is as close as 10 to the power 80, which is a very known number. As well as describing 6 more numbering systems, and above all, leading to a number equivalent to 10 to the power 421. So they could visualize all that. It's not that we only have no numbers. Then this famous Pythagorean theorem was said in Shulba Sutras. See, our ancestors never believed in naming the concept of copyright, the concept of what is this patents were not there those days. The knowledge was for everybody. Once somebody developed something, it was for everybody. It was for everybody. This Shulba Sutras and all that were everybody. They never named it after them. We are only now calling it was a statement by Bodhyayana, it was something by Aryabhatta we are calling. But they never named it that way. Any inventor for that sake would never name it after them. So if you have some theorem on somebody's name, we are calling it in his name. He has thrown it open to the world. In fact, every knowledge is hanging, every knowledge is from him only. Then, so the square root of root 2, square root of 2 could also was also computed this way 1.414256 correct to 5 decimal places. So that was there. We will come to that soon. I will show screenshots. And Jain mathematics is worth mentioning. See, in fact, one of my PhD students did PhD in Jaina logic. You have heard about what is this binary logic. It has two, true, false, false, true. Only two are there. But I have seen in this Jaina logic, the third concept of indeterminate was introduced, and there were seven, what is this logic. So it was a sevenfold logic, and true, false, along with indeterminate, true and determinate, true and false, okay, true, false, and determinate, like that. Seven were there. But very surprisingly, this was very much similar to the what is this binary logic, and they could even solve some problems of artificial intelligence, I'm telling you. So that concept could be effectively used. These Jain mathematicians recognized five different types of infinities. Okay, infinity in one direction, infinity two direction, that's what we do in real, and infinite area plane, and infinite everywhere. Okay, and so if you see many kinds of infinity, that's in fact only one infinity, but in real line we see as two, in plane we see it in every direction, like that. So there were discussions on countable sets, uncountable sets, and infinite. Where was the need for countable sets? I don't know, but you have, maybe I will tell you about countable sets. That's a set for the students. Sets are there, you know about sets. But you know about finite sets. Finite sets will have finitely many elements. So in this Zoom meeting, there are about 160 students, 170 students. That's a finite set. And yeah, infinite set is not a finite set. Maybe the set of all stars in the sky is an infinite set. Then what's the need for countable set? Countable set is a set which can be set in a one-to-one map with the set of natural numbers. That is, you can count them one by one to infinity. You can keep on counting; it will never end. But you can count them 1, 2, 3, 4, like that. You can keep on counting. If you are not able to count, it's uncountable set. Uncountable sets are there. The set of rational numbers are countable. You can count them. And the set of real numbers uncountable. You cannot count it. It's like in bulk of sand, you cannot count sand. The earliest recorded usage of circle character for the number 0 usually attributed to the 9th century. Okay, just see it. The ancient Hindu symbol of a circle with a dot in the middle, known as Bindu, symbolizing the void and the negation of the self, was probably instrumental in the use of circle as a representation of the concept of zero. It was there. See, the thought patterns were different. They would not have called it zero. Okay, they would have called it shunya. The idea is, the thing we should know is, these concepts were there those days. It's not that our ancestors couldn't think. It's not that we only developed mathematics, physics, chemistry, and all that. The thought process was there already. We are sons of that heritage, and we should be able to think even ahead of them. Okay, even ahead of everybody. We have that rich heritage. We should have that in mind. Right. This Brahmagupta established certain basic mathematical rules for dealing with zero. So he could say what is 1 plus 0, 1 minus 0, 1 into 0. Okay. Then they thought about 1 divided by 0 also. I will come to that. They were thinking about 1 divided by 0 also. So if you keep on dividing 1 by smaller numbers, what would happen? They have thought about it. Okay. I will come to that. Then the astronomers heavily used trigonometry concepts, and you see the similarities, similar measurements for sine, cosine, cosine, tangent, and all that is there. See, Indian trigonometric tables showed that an angle of 1 by 7 degrees indicates the triangle sides with a ratio of 400 is to 1, meaning that sun is 400 times farther away from the earth than the moon. So those days, this astronomical findings of India are astonishing. Okay, they have, without the telescope and all that, they have gone for it. They have, they could tell the distance of sun from Earth, and which greater than the distance of Earth from the moon. Right. Uh, then they have thought about pi. They were thinking about zero. Then they have thought about pi also, the value of pi that was taught. And you must be knowing Ramanujam has given the decimals in pi in astonishing way. How he could get, see, he has made one statement, Ramanujam, that he said the equation means nothing to him unless he is a message of God. So he felt he when some he has it's recorded in his history that these equations flashed to him were flashed to him by his goddess. That is there. See, what we should understand from that is every knowledge is God from the infinite. See, whether if you believe in God, you say God, or it's natural. It comes from the nature. What we should feel humble in realizing that all the knowledge comes from some infinite source. Every knowledge is already there. Every knowledge is already there. And then and there, see, this what is the gravity was already there. It's not that man invented it. Gravity was already there for since the time immemorial. Okay, this gravity concept is there, but we have given name to it. We have given name to it. See, our ancestors have built temples, big temples, the big temple in Tanjore, and you see without measurements, without understanding the nature of gravity, they would not have built that. Okay, the Gobram of Pisa is there, and it is seen because it is tilting. Okay. But we built temples, very big temples with feet of, I mean, very high, very tall towers we have constructed. They are standing for thousands of years. So they had the knowledge of this trigonometry. Maybe it's all gone. It's all gone. So some of them are remaining, and some have made the efforts to document it. See, for example, Bhaskara, he thought of dividing 1 by half. Then you get 2. Dividing 1 by 1 by 3, you get 3. Like that. So, if you smaller and smaller fractions yields a larger and a larger number of pieces, ultimately, therefore, dividing 1 into pieces of 0 size would yield infinitely many pieces. That's what he thought. See, look here, x gets bigger as 1 by x approaches 0. Conversely, x gets smaller and approaches to 0 when 1 by x approaches infinity. This is our modern graph. This thing is there, but it was thought of, people have thought about it. This history of development of mathematics in India is as old as civilization of its people itself. The ancient Sanskrit literature, any literature, the Jaina literature, Buddhist, okay, many literature are there in ancient Indian literature, contain enough materials to help form a good idea of mathematical ability during that time of development of this class of literature. See, they were capable of thinking. That's what the Shulba Sutras, we will see shortly about it. They are a storehouse of enumeration, arithmetical operations, fractions, surds, rational numbers, whatever that were needed those days. Those days, people conducted yajnas, yagas were conducted. And you will see references how to construct these yahagundas, in what shape. They are all geometrical shapes. How to construct if a yaga gunda is of triangle shape, how to construct a smaller yaga gunda of similar triangle. Similar triangle concepts were there. A smaller model would be there, how to blow it into a bigger model. That was there. What do you mean by this word shulba? It's sulva, meaning rope. So they were using ropes to measure. Linear ropes were there, spatial ropes were there, three-dimensional figures. To measure them, they used this sulvas, strings. So this bodhyayana, This apastamba is how do you get by apa is water. So he could make a pillar out of the water. That's what his name is apastamba. Apastamba. He could make a stamba out of apa. Okay. So he knew the trick of making the water into a pillar, stamba. Then Katyayana Shulba Sutras were there. So these were dated back as this 500, 600 BCs. Now let me have certain screenshots from the books, two books I referred. We will look into it. Maybe I have chosen these slides in such a way which some concepts which would be familiar to the first year students. So engineering students, they study engineering mathematics. What's that engineering mathematics? Is in the earlier those days, there was nothing like mathematics, physics, chemistry. I don't see. Go back to the dates of even Archimedes. You will see that they were just philosophers. They were just philosophers. One guy would be doing physics, chemistry, mathematics, biology, whatever it is. One guy would be a scientist. He would be a philosopher. See, even in these centuries, in the days of our forefathers, grandfathers, doctors used to be there. You must have seen in cinemas, doctors even would come to our home holding a big bag. Okay. There were just general doctors, MBBS doctors. Once somebody finishes MBBS, he would be able to handle everything, whatever the man gets ailments. Later, slowly we developed into specialists, a specialist for the left ear, specialist for the right ear, like that it has become now. Okay, so it depends on the need. Depends on the need. Those days, the needs were basically geometrical. They needed this geometry for constructions. Just to have a look at it. The theorem of square on the diagonal of a rectangle. The areas of the squares produced separately by the length and breadth of a rectangle together equal the area of the square produced by the diagonal. This is what is known nowadays in the name of Pythagoras. You call it a Pythagorean theorem. Okay? Those who can read the Sanskrit can read that also. Dirgha Chatura Shayakshana Yarajhu Pashwamani Triyangani, three angles, Triyangani cha Yat Prutak Bhute Kurutas Tubhyam Karoti. I am not going to read every sloka like this, but you should understand it is reference is given got from Shulpa Sutra, so that it says the Pythagorean theorem was there. It was needed somewhere. So they needed to get the length of the hypotenuse of a triangle. When they are attempting to do that, they came to know about root 2 also. Next one, the theorem from Manava Shulpa Sutra. This was from Bodhayana Shulpa Sutra. This is from Manava Shulpa Sutra. It says, multiply the length of a right angled triangle by the same length and the breadth by the breadth. The square root, see, they have put it like that. The square root of the sum of these two results gives the hypotenuse. This was already known to the scholars. This is illustrated by the diagram over there. So why is it is known in the name of Pythagoras? Because we studied this Western culture, and we are convinced that only the Britishers could think that way. Our Westerners could think that way. We should feel proud that we also had these similar thoughts. See, somebody would have thought about cycle. The fellow who thought about the wheel, the fellow who thought about the cycle were great. You should not say, see, this fellow invented cycle, never called it a cycle. You in the earlier days, you must see, go to the Google and see, the cycles never had two equally sized wheels. One wheel would be small and the other wheel would be very, very big. They thought of like that. See, they thought of commuting fast. They were thinking of the means to commute fast. Okay? So that's why the concept of cycles came. Now in these days, so you have got bikes which can run at the speed of 120 kilometer per hour. You should say, no, no, the forefathers were, see, what they invented just a cycle. We have invented this motorbike which runs 120 kilometers per hour, but the cycle would go only 5 kilometers per hour. Don't forget, the invention of bike is based on that invention centuries ago, years ago, decades ago. Somebody invented wheel. They would not have thought what people would do with this wheel. They would have used it just for transportation. Moving the movement of objects would have been easier for them. Okay? So somebody invented that wheel. Somebody improved it into a cycle, and we have improved into earlier days. Scooters were there. You must have seen them. Scooters with gears and all that. Now you have auto geared scooters. But to remember, all these are based on the findings of our forefathers, whoever it may be. Now, this is what I told you already. The diagonal of a square produced double the area of the square. The theorem of square of the diagonal of a square, right? So this also says that here the concept of square root of 2 steps in. Square root of 2 steps in. How the value of square root of 2 is computed? Just see it. The measure is to be increased by its third, and this third again by its own fourth, less the 34th part of that 1/12. This is an approximate value of root 2. So given it like that, root 2 can be computed like 1/3 and 1/12, and then you subtract this uh, 34. 1 by 3 into 4 into 34. You subtract this. They have done it in 800 BC to give the value of square root of 2. Why do you need the value of square root of 2? It comes in certain geometrical shapes. So you can, this is my favorite question to ask students. Can you draw a line of length 2? They will happily go and draw with scales. Can you draw a line of length root 2? So most of the students will be blinking. So they would finally, some guy will come up and say this Pythagorean theorem with the rectangle, right angled triangle with both sides 1, the diagonal will be of length root 2. So you can construct a line of length root 2. Then you ought to know how approximate is that length is. Whether it is between 1 and 2 or 2 and 3 or 4 and 5, you need to know. So that is what people were interested in, finding the value of root 2. Next, root 3 gets in. How the concept of root 3 is coming? When the breadth of a rectangle is a unit in measure and its length is root 2. Now from root 2 you come here. How did you construct root 2? Triangles of side 1, 1, then the diagonal of length root 2. Now you know how to draw a line of length root 2. Have a rectangle with one side 1, another side root 2, then I am getting the diagonal as root 3. I am getting root 3. Trikarni. This root 2 is Dvikarni. This is Trikarni. So how do you get this Trikarni? You are getting root 3. Now let me get into pi. What is pi? This you know that this 2 pi r is the circumference of a circle. That is how this pi has come. Pi is a ratio. We have approximated it into 22/7 and all that. That's very interesting to note that the algorithm for a value of phi has been given by Aryabhatta. This after Christ, 476. These numbers we are writing, but he has given the perimeter of a eight-sided inscribed regular polygon in a circle of diameter 20,000 units is 62,832, and it approximates the circumference of a circle. It has come that way. See that the pi, the ratio to the circumference and diameter of a circle, they have got for certain. Why do you have these numbers? Because it was the need of that day. Okay, they needed this measurement for some structure they were constructing, and that ratio, you see that it is 3.1416, etc., etc., etc. This was enough for them. This was enough for them. See, those days, certain numbers were enough for them. You go to some fellow who manages the sheeps, he may not know beyond number 20, for example. Hmm? And he is bothered only about number 20. We never had a sheep beyond 20. You go to him and ask him, how many are there? You show 5 sheep, he will say 5. How many are there? You show 10 sheep, he will say 10. But to go to him, show him 30 sheep, ask him how many are there, because since he could count only up to 20, he would say many, many, many. So many are there, I don't know. You show him a group of 100 people, ask him how many are there, because he knows to count only up to 20. He will say many are there, infinite. I don't know, many, many are there. So the concept of infinity slowly sets in when we run out of words to describe a bigger number. Infinity is not a number. It is never approachable. It is sitting there. But if you try to approach it, it will go away. It's like our God. Okay? You try to understand him, he goes away. Yatavasata nivartante. These words won't reach there. You try to describe God by word, you try to describe the Brahman by word, it will go away. So try to describe infinity by a number, it will go away. Whatever number you say, it goes away. So these concepts were there earlier. Then this pi, just look at it. This how this ratio of pi, the number of pi was obtained. Then this is, yeah, the value of phi in Aryabhatiya, 100 plus 4 multiplied by 8 and added to 62,000. This will approximate the circumference of a circle of diameter 20,000. Just look at the same one which I sold here. See, it is giving the value of pi. They needed pi, and they could estimate the decimals of pi. Okay. It is not that we didn't know anything about irrational. We would not have called it. They would not have called it as an irrational number. They just need pi root 2, root 3. Okay. They just used it. Others were not useful to them. But later, these people gave name to it. These people gave name to it. See, earlier, these people would have used the tamarind fruits to make something. Nowadays, we are calling it sambar. Those people would not have called it sambar. Now we are distinguishing between sambar, rasam, kutu, poriyal. Everywhere that tamarind is used, the fellow who used tamarind the first days would not have called it sambar. Okay? They would not have even known it as tamarind, some fruit. Now we have so many fruits, we are giving names to it. Yes. The Madhava from 1350 to 1410, and Leibniz also. Okay, Leibniz. See, these big people think alike. Even these days, you will see a mathematician, a scientist would invent something. In some other corner of the world, somebody would be inventing the same thing. Nowadays, things are very easy. Whatever you do, it is made known to the entire world. If you do a PhD, your thesis is to be uploaded in Shodhganga. It will be hanging over there. Lakhs of theses are there in a website called Shodhganga, where you can see whoever has done whatever in PhD. Those days, it was not so. People could hardly communicate. There was no phone. Okay? But it is understood that great people think alike. Great people think alike. There have been instances when two disciples of two different masters, okay, they met the masters on the same day, same time, at different places, hmm, the masters talked about the same concept. The masters talked about the harms done by the shift system. Okay? To one disabled, one master was talking, to another disabled, another master was talking. But when the disabled met, they were surprised to know the masters talked the same concept on the same day, same time. So likewise, this Madhava thought about this power series of phi. Leibniz also thought about the power series of phi. See how the power series of phi is developed. Pi by 4 is 1 minus 1 by 3 plus 1 by 5. So that is Leibniz. And the sloka over there says about how Madhava also thought about it. This is a very light exposure to the concept of trigonometric functions in Indian mathematics. You know that the concept of sine, cosine, tangent grows out of the how the angles are measured. There you had this Jya, Kotijya, Utkramadjya. Three concepts. They were very similar to the sine, cosine, and tangent concepts that was there. And the reference is given at the bottom. These are taken from the book by, I showed you in the beginning, which book? This book. I am using slides from this Bharatiya Ganitam. If you're interested, this can be ordered from Rashtriya Sanskrit Vidyapita. It's available. Yes. Let me be on track. Yes. Then the radian measure of angles, you know that there are two measures of the angles, okay, the degree and radian. The radian measure of angle was also there. This pi is a radian measure and 180 degree is a degree measure. It is surprising to know that the radian measure was also measured. It was used for calculations. Then the concept of infinity was there in the Bija Ganita of Bhaskara. They were thinking about, see, as I told you, when you divide n by 1, in 1 by 1, you get 1. When you divide 1 by 1 by 2, you get 2. When you divide 1 by 1 by 3, you get 3. When you divide 1 by 1 by 100, you get 100. So this amused them. So when you keep on dividing by smaller, smaller, smaller numbers, you are getting bigger, bigger, bigger numbers. How to call that big number? They have called it Purnam. See, the activities as you see, nothing can be added to infinity. If you add something to infinity, it becomes infinity. Nothing can be subtracted from infinity. If you subtract 8 from infinity, it becomes infinity. So it says somehow similar to this Purnamada Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Vashistate. If you take a small number from infinity, it's again infinity only. Okay? That the thoughts were there. Every thought, every mathematics, everything is philosophy. If somebody gets a PhD, what's the expansion of PhD? Doctor of Philosophy. That means that fellow is able to analyze something logically. He is able to take his own problem and solve that problem in his own way. Okay? So the fellow PhD is a doctor of philosophy. Everything is philosophy. Not only Vedanta, not only this, your mathematics, physics, chemistry, whatever you study is philosophy only. It is taking us to the more we learn, the more humble we should become. We should know that's a more of thing we are supposed to know. Okay, just have a look at it. The value of n by 0 plus any large number is value of n by 0. Then the words as numerals, the value of pi in Leelavati, value of pi in Leelavati. The diameter of a circle multiplied by 3927 and the product divided by 1250 is the nearly accurate circumference. Just have a look at it. The circumference is given by the formula is given in the book by Leelavati. The alphabets were this called Katapayadi Sankhya. Katapayadi Sankhya. We used these letters, alphabets to represent numerals. Na, Nya represent 0 and Katapaya denote 1 and their successive alphabets denotes other successive digits. The vowels are to be ignored, the last consonant is to be taken. That's a very big, very nice formula how this Katapaya, the Sankhya is calculated. See, those days when they want to give the date of birth of somebody, they would use this Katapaya Sankhya and write a sloka. So from that, the date of birth of that person, say Adi Shankara, can be found out. Okay. They were usually given in the form of slokas. Those days, people never had books like us, the tabs where you can record and have secondary memory. They were primarily dependent on their primary memory. So they had to by heart everything. So if a number is there, they would put it as a sloka. For example, I will tell about the year 1865. A historic event happened in that. I forgot what is that. But still, the way my master taught me, he would say 100 dozen orange. 100 dozen. 1.5 dozen orange. He told like that. So that I never forgot that 1865. This 1865 is a very important year in the history of freedom struggle. This 1865. This is called 100 dozen orange. So it's like a sloka. So those days they did like that. But whenever they wanted to remember something, they put it in the form of a sloka. Okay. So these numbers were written in the terms of this Katapayadi Sankhya. Katapayadi Sankhya. Just have a look at this 1, 2, 3, 4, 5, 9, 0. They were written like this. And if you put it as a word, then automatically it will represent the number. Right. So far we had certain glimpses from that book. Now I am getting into this book. Yeah, The Scientific Thoughts of India by an octogenarian Dr. C. Krishna Nambudri, written in Malayalam and translated by Narayanan Nambudri to English. I have read this book. I have written a preface for this book also. So I acknowledge this book and show certain pages from this book to induce curiosity in you to get this book and read it. Yes. There were thoughts to find the time taken to fill a pond. Time taken to fill a pond. The discussion is on the time taken to fill a pond by opening different pipes simultaneously. You would have seen it in calculus, applications of calculus. You might have studied in +2. This is given as a sloka. If you open only one stream at a time, the pond will get filled respectively in 1 day, half day, 1/3 a day, 1/6 a day. If they are all opened simultaneously, by which part of the day the pond is completely filled? It says we recover 1/12 a day. This is given as a sloka. In Leelavati. Right. The unknown quantities from sums of all but one. See, this is solving simultaneous equations that we are doing nowadays. See, when you get a real life problem, like you want to know see, I can simply say 10 kgs of potato and 12 kgs of tomato cost 100 rupees, and 6 kgs of potatoes, 4 kgs of tomatoes cost 50 rupees. What is the rate of potato and tomato? You would form it as a simultaneous equations of x and y and solve it. But these needs of solving simultaneous equations keep coming, and it was there those days also. It is in Aryabhattiyam. From the sum of all unknown quantities, subtract the first quantity, second quantity, etc., and add them together. Divide this quantity by number of quantities less 1. The quotient thus obtained gives the total of the quantities. That is there, right? You see this beauty of solving. Yes. Then extraction of square roots. What was the need for square roots? I wanted to know. See, I wanted to make a room of plinth area 100 square feet. Then what should be the size of the, the length of the sides? What should have been the length of the sides? That is natural. See, some scripture would say you construct Yahagunta of this area. Then I should know what should be the size of. If I say it should be 4 square feet, then I should know the side should be. Then I will get the concept of square root. Concept of square root comes in. See, understand again and again the concepts of mathematics that were developed by them were put to use immediately. When they needed something, they went for that concept. Okay. Any science is like that, mathematics, physics, chemistry, you develop something when a need arises. The necessity is the mother of inventions. When you need something, the concepts come. When this concept of complex numbers come into existence, you needed numbers for counting. Then I said the negative numbers were added in, and the ratios were added in, and the real numbers were there to measure anything and everything, rational or irrational. Then they were trying to solve certain equations. When they were trying to solve the equation x square plus 1 equal to 0, the concept of complex number stepped in. Okay. Then the concept of pairs of numbers stepped in. Okay. So the necessity is the mother of invention. So whenever you need something, you will think of solving it. So that's why our PhDs, our research must to focus on that. You should take up a topic in research unless so that the topic is solving certain societal problem. Then only it is long living. It will be there in the minds of people forever. So just to have a look at it, the way Bhaskara suggests, from the Varga place, subtract the largest possible square. The root of that square is the first digit of the square root, write it above, divide the avarga, which is not varga, okay, place by double the square root. Repeat this procedure. That's what Aryabhatiyam says. It is in 2.4, Aryabhatiyam. Okay. So that procedure gives you how to find the square root of 576. Okay. The square root of 576 is 24. You get that. Next, certain glimpses only I am showing. This book has hundreds of pages. To construct a square which has twice the area of a given square. So when this thought would have come, some room should have been there. The king would have asked to construct double the size of this room. Go ahead. Double the size of this area. So how do you double it? How do you double it? It's a diagonal of a square makes a square which has twice the area of the given square. This comes in Apastamba Shulba Sutram. Apastamba Shulba Sutram 1.5. It is given over there. How to construct in the ratio 1.2. Next, people keep entering the hall. Factorial. The concept of factorial was there. If the weapons of rope, hook, snake, small drum, skull, trident, staff, spear, arrow, and bow are held in the 10 hands of Shiva, how many different types of Shiva idols can be there? See, such a thing. When this comes in Leelavati, if mace, wheel, lotus, and conch shell are held in 4 hands of Vishnu, how many different idols of Vishnu can be made? This gives rise to the concepts of Shiva. And 1 into 2 into 3 into 4 is written as 4 factorial. For Shiva, the weapons can be held in 3, 6, 2, 8, 8, 0, 0 ways. So some thought was there. Right. Then the combination of possibility of 6 states, 6 tastes. See, you think, you go to the hotel and there's a variety. 6 varieties of dosas are there. You must have seen in certain 100 varieties of dosas sold here. What do you do? See, it will be a very small shop. He will have one dosa batter. He will have some in 10, what is that, in 10 baskets, 10 small containers. He will have onion, tomato, this, that, the powders and all that. So all these combinations will give him 100 different dosas. If you want onion dosa, he will put that batter and put onion and tomato. Okay. If you want this capsicum dosa, he will put capsicum. So when there are yeah, 2 varieties of batter and 10 varieties of chutney, 4 varieties of sambar, and how many varieties of plates can be there? Such discussions were there in Sharaka Samhita. In Sharaka Samhita, this combination was tested. See, this combination is everywhere. Suppose you have 6 horses and 6 warriors to ride the horses. In how many combinations these 6 men can ride the 6 horses? This possibility could have been there. So this concept was very much there. Next, the introduction of numbers were there. Introduction of even numbers and the multipliers of 10 are also there. Just have a look at it. See, it's Ekasmai Swaha, Tribhyah Swaha, Panjabhyah Swaha. Like that, they are making 1, 3, 5, 7, 9, 11. It comes in, what's that? Taitriya Samhita, right? It comes in Taitriya Samhita. Salutations to 1, salutations to 3. So it's very interesting to see that they are counting these odd numbers. Counting odd numbers. Next, the arithmetic progression concept was there. Salutations to 4. Chadubhyaha Swaha. Ashtabhyaha Swaha. Dwadashabhyaha Swaha. Like that it goes. Shataya Swaha. Salutations to 100. So it progresses 4, 8, 12, 16, 20, like that it goes. It comes in Taitriya Samhita. They never called it arithmetic progression, but it was there. The thinking was there. How to count odd numbers, how to count even numbers, how to count in multiples, how to go for progressions. Next, you see the multiples of 5, the progression in 5. 5 is a number and it goes 5, 5, 5 added. Okay. Panjabhyaha Swaha. Dashabhit all came in these rituals. They were living on rituals only. No other. See, dear, nowadays we are in a hurry. We just to do 5 minutes puja in the morning and run away. We have other business to do. But their whole business was that. Their whole day was spent on this study of scriptures, looking for the Brahman. Nowadays, what happens? We have studied so much and we are saying, I have no peace. I want to know what is there. I want to know what is there after that. I want to know why should I do good? All the basic questions we are asking now, all have been answered years ago. Years ago. So their thought process was that they were thinking about the aim of life, why we are born, the aim of life. They thought like that. They worked towards that, and we are living our life now. We have moved away from our roots, and now we want to. When we want to know what our forefathers did, then we come to know about all this. This kind of, they never did it for the purpose of developing arithmetic progression. They developed this concept to suit their needs, to help in their yajnas and all that. But we are now comparing that the arithmetic progression concept was already there. I will be completing shortly in 10 minutes. The geometric progression was there. This is geometric progression: 100,000, 10,000, 1 lakh, 10 lakh. See? 10 lakh, Pramudaya Swaha. This all they are offering oblations to the fire. Okay. And it goes up to 1 lakh crores. This comes in Taitriya Samhita. See, 1 lakh crores. From 100 to 1 lakh crores, this geometric progression concept was there. We are naming it as geometric progression now, but it was there like that. Shataya Swaha, Sahasraya Swaha, Ayutaya Swaha, like that. Triyutaya Swaha, like that it goes. So the geometric progression concept was there. Then let me come to this numerable, and infinite. This comes in Brahma Purana. The concept of countable, uncountable, infinite, finite. Don't think they have come now. They have thought about it. This Samkhya, they call it Sankhya, countable, is that which can be determined using Sankhya. You can count it. If one quantity cannot be determined practically using numbers, it is innumerable. It is held like that. Calculating the number of sand particles in the world is unimaginable and it is infinite. Infinite is beyond description. That's beyond the usual rules of mathematical operations. For example, if 1000 is added to infinity or 1000 is subtracted from infinity, the result is infinity. Purnasya Purnamadaya Purnameva Vashishyate. Purnamadaha, infinity is there. Purnamidam, infinity is here. Okay. Purnat Purnamudashyate, that is our philosophy. Purnasya Purnamadaya Purnameva Vashishyate. It says in nutshell, they never talked about infinity, they never called it infinity. For them, they wanted to say everything is divine. We are divine. We have come from the divine and we are divine. That concept was there. We are now trying to dig into it and saying that our people knew infinity. Our people knew everything. Our people knew everything. They knew the very basic of life. They got into the very root of all questions, eh, very root of all questions, knowing that we will know everything. Knowing that we will know everything. See, there was a lady who went to a saint with hundreds of questions. Hundreds of questions, very big list, like Maliga list, Mary, big list was there. She went to that saint with a big list. The saint was in Dhyana. This lady sat before him, okay, with a very big list. As soon as the eyes are open, she will read out everything. That was the intention. The saint opened his eyes, just had a look, straight look at the eyes of this lady. This lady started folding the paper. The disciples are, you can ask questions. No, no, no questions. All questions vanished. How all 100 questions could just vanish by a look? See, it is the way we start thinking. We have 100 questions. Students, you will have 100 questions, 1000 questions in your mind. You will be having a lot of questions. Why that is like that? Why did I get this much mark? Why did I join this college? Why did I not join that college? All questions will be there. Why my father was like that? Why his father is rich? Why I am rich? Questions, 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 questions. We have questions. But once you make an attempt to know your true self, I know I am digressing. Once you make an attempt to know your true self, how will you come to know your true self? When you start to appreciate what your forefathers did. Okay? Have a pride, stand on the shoulders of giant, stand on the shoulders of your forefathers. Come to know that you are not a sheep, you are a cub, you are a lion cub. Your forefathers were lions. They did everything for you. They could think ahead of, they could think very innovative things those days. Okay, if you think of some infinity here, it is already thought of. It's not that our ancestors invented aeroplane. Okay, it is not that. It is not that. The thought process was equal. Thought process was similar. They thought, why don't you? Why can't you fly like a bird? This thought was there with them. So that that was the seed for the Wright brothers to invent the aeroplane. So have this, go through these books in your, let it be your tea table book, let it be your bedside book. Have get hold of certain books of this kind, learn a bit Sanskrit. Okay? Then you will come to know about our rich heritage. Once you come to know about our rich heritage, that is the very purpose of this lecture. I thank the authorities of PSG. They thought about this topic. I have talked on spirituality to different groups, not in academic circles. I have talked about the mathematics, mathematical modeling, automata theory modeling, graph theory, and the achievements of engineering mathematics and all that to students. First time, yeah, engineering college has asked me to talk on ancient Indian mathematics. I thank them for their vision they have in their mind. So let the students know this. I know that I have been fast. I have tried to introduce as much as possible in this 1 hour to give you some curiosity, some appetite to learn this basic concepts. Thank you. Hope certain books can be shared by me. This PPT will be shared by me. Hmm? Have a look. Have a look at the ancient findings. Have a look at your Upanishads, Vedas, and whatever forefathers used to say. Have a look at this Indian mathematics, China mathematics. Okay, whatever. Come to know what your father did for you. What your we may not be knowing what our fathers has been doing, what our grandfather has been doing, what they have achieved in their life. Come to know about it. Why? You will gain confidence. You will gain confidence. You will gain confidence that our forefathers were cubs, they were lions, they were giants. They could think anything, they could do anything, they could achieve wonders. Why can't we? So you will naturally get your morale boosted. Your morale boosted. Hmm? Okay. Thank you. Thank you so much. So I am stopping here, leaving the session to the authorities. Yeah. Thank you.
So thank you, sir.
Yeah.
So a very happy morning to all. So it's an honor to have been asked to propose a vote of thanks on these occasions. So on behalf of IAPAJ student chapter and the Department of Mathematics, I extend my very heartfelt vote of thanks to the Honorable Resource Person, Dr. T. Venugopal, who blessed us with his presence and took a valuable time of his busy schedule. And his insights on astronomical findings and ancient Indian mathematics. So it was very, very informative, sir. So last but not least, our heartfelt thanks to all our student friends and Vice Principal sir, and then HOD ma'am, and then all my faculty colleagues for their active participation in this webinar. So with these warm words, I extend a kind message. We move to the end of this today's webinar. So I thank you one and all. Thank you.
Thank you then. So kind of you. I'll take leave.
Thank you, sir. We are signing off.
Thank you. Thank you. So kind of.